Hi, EmacsConf 2025. My name is Ramin Honary, and I'd like to talk to you today about my project called Schemacs, which I presented last year. Back then it was called Gypsum, and the name has since changed. So, my name is Ramin Honary. I'm an Emacs enthusiast, have been since 2017 or so. I'm a full-stack software developer. I love Haskell, Scheme, anything functional programming related, and of course Emacs. I started learning Scheme about 3 years ago, and this is my third time presenting at EmacsConf. So the Schemacs project that I'm talking about to you today was originally called Gypsum, and the reason I did not call it Schemacs was that the name Schemacs was taken on GitHub. But in the past year, I was able to get the permission of the author of GitHub's Schemacs project to name my project the same thing, even though it's a very similar project. And so I changed the name. Let me see if I can quick show the screen. So yeah, I have archived the old project. It's still there, but there's an explanation in the README file and a screen grab of the conversation I had with the original author of GitHub Schemacs. My Schemacs is not on GitHub at all. It's only on Codeberg. So please don't get confused. But yes, I received permission to change the name, and so I did. And I would like to give a quick shout out to user Tushar Hero for helping me with that. This person really helped make that name change happen. So, back to the slides. And so now I'd like to clarify the scope of the project. I don't think I quite made it clear well enough last year, but although I'm definitely cloning the Emacs Lisp programming language, the actual scope of the Emacs project, or the Schemacs project, is to make an Emacs-like app platform for Scheme. I don't consider Emacs to be a text editor. I consider Emacs to be a Lisp app platform. So it's similar to something like the World Wide Web or Microsoft's .NET app platform or Java. These are all examples of app platforms. And I would like Schemacs to make it easy for not only people to use it for things like editing text, or using your computer through a command line or manipulating your Git repository. I'd also like you to be able to create simple GUIs or TUIs using Scheme. So that's also one of the goals of this project. It will of course have an Emacs-like text editor, and I will clone Emacs Lisp. So hopefully GNU Emacs users will feel comfortable moving over to Schemacs because they'll be able to use you'll be able to use your init.el file. So configuring and scripting Schemacs should be done in Scheme. I'd like to encourage scripting in Scheme and creating new workflows and macros in Scheme. It will support Emacs Lisp, depending on how much of the Emacs Lisp interpreter I can clone. That will be supported, but not encouraged. But you should still be able to run your init.el, and I would like it to be good enough, the Emacs Lisp interpreter should be good enough to run packages from ELPA, although it will probably be some time before it will be able to run something as large as org mode or Magid. It is slightly different from the Guile-Emacs project. This is the work of Robin Templeton, who presented last year. Guile-Emacs links the Guile runtime into the Emacs executable. It's not a Scheme application. Emacs, the core of Emacs is written in C. Guile, the core of Guile is written in C. What Robin Templeton has done is, at the C level, linked libguile.so into Emacs, and then provided a programming layer where you can call the scheme interpreter from Emacs Lisp, so that you can run Emacs Lisp, or I'm sorry, you can run scheme programs from within Emacs without having to launch a separate process and communicate over a channel such as a socket. You won't need Slime or anything. The Guile interpreter is just right there inside of Emacs. But my project is not like this at all. Schemacs is written completely from the ground up in R7RS compliant scheme, and it because it's R7RS compliant, it's not bound to any one particular scheme implementation. Although Guile is a reference implementation, one goal of this project is to be able to run Schemacs on any R7RS compliant scheme implementation. The work that I've done this past year mostly is internal. There's not much that you can see on the surface. But one of the most important things that I did was I rewrote the parser in R7RS scheme. So it no longer depends on the Guile regular expressions library. The parser now also provides source locations. So if an error occurs in Emacs Lisp, there will be a stack trace, and it will show you where in the source code the error occurred. This was not possible last year. And because it no longer depends on Guile, I can make it work on multiple scheme implementations, and so far I've been able to get it to run on the Chibi scheme interpreter and the Gauche scheme interpreter, as well as Guile, which is the reference implementation. For a short time it did work also on Shea Scheme, the Shea Scheme compiler, using Gwen Weinholt's Aku, which is a program that translates R7RS scheme to R6RS scheme. And with that translation, because Shea Scheme is pretty strictly an R6RS compiler, the translation allows you to run R7RS programs. But due to some change, I'm not sure where, it may have been changed in the Schemacs source code, or it may have been a change to Aku, but it no longer builds on Shea. It did at one point. I'd like to try to fix that. The second most important thing that I've worked on is a portable React-like GUI. And so React, for anyone who has done web programming, is a very popular framework for programming web applications, and I've provided something very similar to that in Scheme now. So it works. I've constructed a DOM data structure in Scheme. It's just an ordinary Scheme data structure. It works like the web's document object model, or the DOM data structure. And then this Scheme DOM data structure can be rendered using any GUI framework that is convenient for the Scheme implementation that you're targeting. And you should be able to implement also rendering to a CLI as well. The current reference implementation is using a framework called Guile-GI. This is the G-object introspection framework. It's a very simple G-object introspection framework for Guile, and it binds to GTK3 on Linux. There's a similar framework called G-Golf, which I'd like to begin using as well, also for Guile. G-Golf seems to be a bit more well-maintained, has better features. G-Golf may be a better rendering backend for the reference implementation, but I would like to provide both. And so yeah, I will give a demo of this now. Unfortunately, not a whole lot to see compared to last year. First thing I'd like to show is that I now have a makefile. So you can look inside this makefile, and if you're able to read a makefile, you can see that I have several targets now available, and so you can build Schemacs for Guile, you can build Schemacs for Gambit, or Stacklows, or Chicken, or Shea. Although none of these, except for Guile, currently works. These targets will actually build the source code, but then you would have to load it into the REPL separately. There are targets for launching a Gauche REPL and a Chibi REPL. You can also run the Emacs list tests in Gauche and in Chibi. And you can also start a Guile REPL through the through this makefile. So I will do that right now in the shell. Make the text larger. There we go. Okay, so we have this directory of the source code, and let's just begin by running guile.sh, and this will launch a REPL, and you can load main-guile. This will launch the GUI. This is the basic proof of concept GUI that uses Guile GI. And so it may be hard to see. You cannot change the size of the text yet. And I've implemented the meta : feature where you can eval in the mini buffer some scheme code. String append hello scheme, and it outputs the result in the buffer. This is basically the messages buffer. And that's all the more that I have with it. This is the same state it was in last year. It hasn't changed a whole lot since back then. But I have made additional changes. So first of all, let's quit out of that. You can run, let me just go back into the Guile. You can run the Emacs Lisp interpreter tests, so eLisp tests. And as you can see, it gives you a stack trace. So this is an error that I've been able to reproduce. I know exactly what the cause of this error is. It is not finding a variable because the closure is not correctly capturing its environment. So there should be a variable in the closure, but that variable has not been captured, and so it is causing an error. It is currently loading byterun.el. Let me show you what code that is here. So I've copied into the source repository for Schemacs some of the eLisp code from GNU-Emacs. And so I have this subr.el, subr, and this declares most of the core of Emacs Lisp that's not written in C. And there's also byterun.el, and it can, Schemacs Emacs Lisp can now evaluate this. This is where functions like defun are defined, and def macro. So as you can see, defun itself is a def macro defined right here. It's written in Emacs Lisp itself, defined in terms of def alias. So I can evaluate byterun, I can evaluate macro expand, and the failure occurs somewhere in subr.el, although if you look at the stack trace, it doesn't provide all the necessary information. So it appears to be happening in byterun.el. Really, it's an error that's occurring inside of a macro. And the macro call site is somewhere in subr.el. Anyway, take note of this stack trace. This was run from within Guile. Now, what I've done this past year is make it work on other scheme implementations. So let's use make to launch a Gauche REPL. Now I'm inside of Gauche. This is the command that you would use to launch the Gauche REPL, and I can load the same program, load eLisp tests.scm. You get the exact same result as Guile. So we have two different scheme implementations producing the same result. Let's try make Chibi REPL. This is Chibi scheme, and you can load eLisp tests.scm. Chibi is a bit slower, but you get the exact same result. So we have 3 different scheme implementations, all running Emacs Lisp, and all producing the same result. So I think I'm fairly proud of that accomplishment. I was able to get the code written to the point where it actually runs on multiple implementations. You can also try making it for like other scheme compilers like Schemacs, MIT Scheme, for example, but this will fail. You can try building it for Schemacs for Shay. Let's try Shay. Here we go. And it will use Aku, and it will fetch the necessary dependencies, but it fails. And I haven't been able to debug that quite yet. Stacklos fails for a similar reason. Gambit, chicken, still doesn't build all the way yet. But yes, the makefile at least has places for, if anybody can help me out and get Schemacs to compile on these other implementations, I'd appreciate it. I could probably figure it out myself, but that will take more time. And let me just show you quick the test program. So basically this is the Emacs Lisp test program that I was just running, and it produces an error. All it does is it loads these files here in this order, and it fails right around here. So it's able to load these two. And yeah, that's what I've accomplished on the Emacs Lisp side of things. And the next thing I want to show you is the GUI framework that I've written, which I'm fairly proud of so far. So this is the GUI framework. Oops, I better launch it again. Okay. And let me show you the tests. So here in the tests, you can start to see some examples of how you use it. So here is a counter test, and this is kind of like the hello world of reactive programming frameworks, where you have a state variable, sometimes called an observable. I'm calling it number, and it uses equals to check if the state has updated. If an update occurs and the new value is different from the old value according to the equals function, then a state update in the GUI is triggered as well, initialized to 0. So bound to number. I have a button function which creates a simple button. It takes a label and an action. Right here you see the div command. This is what creates a div. Using the properties, I describe that this div is a push button and the on button push is an action. The action is to update the variable number using whatever function lambda was provided to it. And then the content that you see on screen, that you will see on screen when it runs, is here. You create a div pack, cut vertical. You declare 2 buttons, and then you declare this useVar, which will take the content of this variable here, this observable, and place it into the GUI next to these buttons here. So what you will see on screen is a plus button, which increments. Here's the increment function. A minus button, which decrements, and then the content of the variable that is being incremented and decremented. And so yeah, the advantage of these reactive frameworks is that with very few lines of code, you can create fairly complex interfaces. The less code you have to write, the fewer chances you have to make mistakes. So let's just run this program. This was the counter test. And that is the debug window. Here's the counter. I'm sorry, it's not much larger than this. But here's the plus button, the minus button, and here's the number, 0. And I can increment or decrement as much as I like. So yeah, that's kind of the hello world of reactive programming. And then reboot the next thing I want to show you is this layout test. And I'll just run the test first. So here we have basically a tiling window manager kind of thing, where you can resize the tiles, and then by clicking on these buttons here, you can change the layout. So we can do 2 on the right, 2 up above, or 3 in a row. And so yeah, it does tiling windows. As you can see, once I work this branch into the main branch of Schemacs, I can use that to implement the split window functionality for Schemacs, the editor. And here's what this split, well, here's the layout test that you just saw. So let me make it a bit smaller so it all fits on one screen. So basically, we have the button command again, and then these are the button actions, which basically just changes the layout, and then I have the layout. So this layout is a div. The first div just places 3 buttons in a row. The next layout is a div within a div. So we have one div which places the button called 2 right buttons, and the div above it which places the 3 in a row button or the 2 above buttons. And here's the next. So there's 3 different layouts, and clicking on one of their associated buttons will just change the layout. So as you can see, very little code to create a somewhat complex user interface. That's the advantage of using reactive or declarative GUI programming frameworks. And so yeah, this has not been merged into the Schemacs at the time of this recording, but will be soon, hopefully. And so yeah, I think I've already gone on for 20 minutes, so I guess I'll just end my presentation here. I have lots more to talk about. I guess I will say one last thing before I go, that I would very much like for others to try and contribute to this project. I will do my best to try and help teach anybody or work with anybody, especially even if you don't have much experience with Scheme. I'd like to help everybody try to contribute. Basically, I want to get this proof of concept working. I want to get a stable user interface up and running, and then we can start working on improving the Emacs Lisp interpreter altogether. There are around close to 1,400 built-in functions which need to be implemented. We don't need to get all of them in order to be able to run probably most of ELPA, but as much as possible. We'd like to clone Emacs Lisp, and I need help. So get a hold of me. My project is on Codeberg, and well, I can't show this here, but yeah, I will end it there, and thank you for listening.